Hello, friends. Have you ever wanted to travel through time? Our world holds many mysteries, and one of the most intriguing is the possibility of time travel. This idea has fascinated scientists and philosophers for centuries, and it has also formed the basis for many fantastical tales. But what if I told you that time travel is not just fiction, but part of real science? Today, I will explain how science can explain what happens with time, and whether it's actually possible to travel through it. Let me start by saying that time is not something fixed. In my theory of relativity, which I proposed in 1905, I showed that time depends on the speed at which an object is moving. When you travel close to the speed of light, time for you slows down compared to someone who stays on Earth. This phenomenon is called time dilation. In other words, for the traveler moving at high speeds, time would pass more slowly than for those who remain still. Moreover, my general theory of relativity, proposed in 1915, asserts that mass and energy can warp space and time. This warping leads to the creation of wormholes, which could theoretically be used for travel to different times. When we think about time travel, we can break it down into two primary types: time travel into the future and time travel into the past. Each of these brings its own set of challenges and strange phenomena that we as a society are still working to understand. The first kind of time travel that is theoretically possible is travel into the future. This idea is supported by the principles of Einstein's theory of relativity. According to special relativity, time is not a constant. It is relative to the observer's motion. The faster you move, the more time will slow down for you compared to someone who is not moving or moving much slower. This is known as time dilation. So, if you were able to travel at nearly the speed of light, say in a spacecraft, time for you would pass much more slowly than for people on Earth. Imagine this. You embark on a journey to a distant star at close to the speed of light, spending what feels like only a few years on the ship. However, when you return to Earth, you could find that decades or even centuries have passed. This means you would effectively have traveled into the future, living far less time than everyone else back on Earth. The key here is that time, for someone moving at such a high velocity, slows down relative to someone at rest or someone on Earth. This is a consequence of how the fabric of space-time itself works when you move at extreme speeds. It might sound like science fiction, but it's a phenomenon that has been proven experimentally using atomic clocks placed on fast-moving airplanes or satellites. These clocks show a slight but measurable difference when compared to clocks on the ground. So, while we don't have spacecraft capable of this yet, the concept of time dilation is scientifically sound. The second type of time travel is far more complex, and that's the idea of traveling into the past. This opens up a whole new world of problems and paradoxes that scientists still struggle to fully understand. One of the most famous paradoxes related to time travel into the past is the grandfather paradox. The paradox works like this. Imagine you travel back in time, far enough that you could prevent your own grandfather from meeting your grandmother, or perhaps even stop him from being born. If you succeed in doing this, then your own parents would never meet, and as a result, you would never be born. But if you were never born, then how could you have traveled back in time in the first place? This paradox raises a fundamental issue. If you change something in the past, it could create a contradiction in the timeline, leading to a situation where your actions would make your very existence impossible. If you never existed, you couldn't have traveled back in time, which creates a logical loop with no clear resolution. This is a classic example of how time travel to the past could break the consistency of reality. Such paradoxes aren't just philosophical musings. They are real problems in physics. If time travel were possible, the question becomes, how could we avoid creating such paradoxes? One possible solution comes from the idea of parallel universes or multiverses. In this theory, when you travel to the past and make a change, you might not alter the original timeline, but instead create a new parallel universe. This means that even if you prevent your grandfather from meeting your grandmother, you would be affecting a different branch of the universe, not your own original timeline. Thus, you would still exist in your own timeline, while the new timeline would have its own course of events. There is also another theory called the self-consistency principle, proposed by physicist Igor Novikov in the 1980s. According to this principle, any actions taken in the past that would create a paradox are inherently impossible because the laws of physics would prevent such contradictions. Essentially, if you tried to change something in the past that could lead to your non-existence, the universe would somehow ensure that you could not make that change. In other words, events in the past would always adjust themselves to avoid any paradox. However, while these theories provide some fascinating possibilities, they remain speculative. We don't yet have the technology or the theoretical framework to test whether time travel into the past is actually feasible, let alone how these paradoxes might be avoided. Now let's talk about the practical problems we face when it comes to time travel. While time travel is a fascinating idea, in practice it faces some serious challenges. These challenges are not just theoretical, they are very real obstacles in our current understanding of physics. First, let's talk about energy. We know that time travel is not something we can simply switch on like a light bulb. To travel through time, especially to create a wormhole, would require an enormous amount of energy, far beyond what we are capable of producing today. Let me give you an analogy to understand this better. Imagine you want to bend a sheet of paper. It's easy, right? You simply apply a small amount of force, and the paper bends. Now, imagine trying to bend an entire piece of steel the size of a building. It would take a lot more force. The same principle applies to space-time. To create a wormhole, a shortcut through space and time, you would need to bend space-time itself. The amount of energy needed to do this is incredibly high, likely far greater than anything we can currently generate with our technology. Even if we could create a wormhole, we would need a tremendous amount of energy to keep it open. Otherwise, it would collapse, and we would be unable to pass through it. This is why we say that time travel is still out of reach at this moment in history. We don't have a power source capable of manipulating space-time in such an extreme way. But the energy problem is not the only challenge. There's another issue that makes time travel even more complicated. We don't fully understand what time actually is or how it works. Time, as we understand it, isn't just a simple sequence of events where one moment leads to the next. It is more like a flexible fabric that can stretch and bend. And the way this fabric behaves might not be as predictable as we think. Let me explain it like this. Imagine you're walking on a tightrope. If you pull too much on one side, the rope can stretch and bend in strange ways. But what happens if you pull on the rope too hard or too fast? The whole thing could snap, and we don't know what the consequences would be. Space-time might behave in ways we haven't yet imagined, and we don't have the tools to predict exactly what would happen if we tried to move through it. In simple terms, time may not be as fixed as we think. Just like space, it could be more flexible, and that opens up both possibilities and risks. For example, if you could manipulate time, you might create unexpected changes in the past that affect the present or even the future. This could cause unintended consequences that we might not be able to reverse. So, while time travel may be possible in theory, the unpredictability of time itself makes it a very risky and uncertain endeavor. But time travel isn't just about theory and experiments. It has also taken center stage in culture. Movies and books such as Back to the Future or Doctor Who give us vibrant depictions of heroes traveling through time. These stories inspire us and sometimes make us believe that one day we could ride the waves of time just like these fictional characters. But let us not forget that science is not fiction. In reality, we haven't yet reached the level of technology that would allow us to travel through time. However, these films and books serve as excellent motivation for scientific research and a deeper understanding of this topic. Modern scientists continue to explore the possibility of time travel, though many of these theories remain unproven. Some of them use quantum mechanics and the concept of multiverse interpretations to theoretically explain how it might work. However, at this time, none of these theories have been experimentally confirmed. We are still on the path of discovery, and who knows? In the future, we may solve these challenges and make time travel a reality. So, is time travel possible? Science has not yet given a definitive answer, but we can confidently say that in theory, it is possible. Time and space are far more complex than we think, and time travel may become possible in the future if we continue to study these phenomena. We are all on the brink of great discoveries, and perhaps, in the next century, someone will be able to answer this question for good. As we explore the nature of time, space, and energy, it's important to remember that we are part of an ever-evolving journey of discovery. The future holds many mysteries, and time travel is one of the most fascinating ones. If you enjoyed this deep dive into the mysteries of time and space, don't forget to subscribe to the channel. Hit the notification bell so you never miss out on more fascinating discussions about science and the universe. Together, we can explore the frontiers of knowledge and maybe even unlock the secrets of time travel in the future. Thank you for watching, and I look forward to seeing you in our next adventure through science.